Today's topic is career sense multiple assess, in which we are doing we go through with the two different types of career sense multiple assess. That is, the first one is CSMA CA. CA stands for collision avoidance, career sense multiple assess with collision avoidance. And the second one is CSMA slash CD. CD stands for collision detection. So what it means, career sense multiple assess with collision detection. So let's start with the first one, that is CSMA, that is career sense multiple assess. This method was developed to decrease the chances of collision when two or more stations start sending their signals over the data link layer. Career sense multiple assess requires that each station first check the state of the medium before sending. So what it means, basically, career sense multiple access CSMA is a method. Why it is made? This method is designed to reduce the number of chances of collisions. And why the collision is occur? Because whenever a number of users are there who are using the same channel, or you can say who are using the same transmission media, and they all send their data. Whenever they all send their data, the data that is traveled on the single medium, then the number of chances are there of the collision detection is there. So this is called the career sense multiple assess. To avoid these type of collisions, whenever a number of packets they are traveling on the transmission media, there are the number of chances of the collision. So we have the different methods to avoid this collision. Whenever a collision is occur, so what it means, there are the loss of packets. If the loss of packets are there, so what it means, the data is not received as same as it is as sent by the sender's side. So in this case, in the case of career sense multiple access, it requires that each station first check the state of the medium before sending. So what it means, first it, it sends the medium, or you can say it checks the medium, or it checks the transmission medium, either it is idle or busy. This is the technique on which the CSMA protocol can follow. So the next is, now let's start with the first one, that is career sense multiple access with collision detection. CD stands for collision detection, or you can say CSMA slash CD. Collision detection means they can detect the collision. And this method, a station monitors the medium after it sends a frame to see if the transmission was successful. If successful, the station is finished. If not, the frame is sent again. So what it means, in this case, first station, or you can say the user who sends its data, it checks its data whether this data is successfully transmitted to the receiver side or not. If it is successfully transmitted, or you can say received by the receiver, then it is okay with the sender. If it is not, then the frame is sent again. Why the frame is sent again? Because the particular frames, they are not received by the receiver. So the sender, it sends again these packets towards to the receiver side. Now look at the diagram. A station is there. Look at here, the station A is there and the station D is there. So how it happens? Now at the T1 and T4, these are the transmission times. Let's start with the first initial time, that is T1. Look at on your screens. T1 sends the data. First, you can check the number of stations who sends the data on the particular medium. The station 1 is there, A. Then B is another there. C is also there. D is also there. So what it means, total in this transmission, we have the 4 stations, or you can say we have the 4 different systems who wants to send the data at the same time. So what will happen? Let's see on your diagram. At the time T1, A sends the data is traveled. At the time T4, again the data is transmitted from this device. Now it can be collide over there. Look at this arrow. So what it means, collision occur here whenever a two different packets of two different stations, they collide at the same time, a collision is occur. Now look at here, A is collision detection and abortion. So what it means, the packets sent by the A system, they can be collide with some other packets, and the collision is detected over there, and the packets are aborted. So what it means, whenever a collision is there, the packets lost in the data, or the data is lost in between the transmission. So look at here, at the very next time, the C is there. At the time T2, when C sends the data, at the same time, the frames that are coming from A, they collide with here. So what it means, C collision detection and abortion. So what it means, also the detection is occur over there, and the time T2, the transmission time is T2, and again the C collision detection, and the number of packets that can be sent by the system C, or you can say station C, they can be collide with some other packets, and these packets can be discarded over the network. So what it means, whenever a collision is detected, look at here. First, whenever a collision is occur over here, at the same time, they can detect the collisions whenever the packets are lost. So automatically user A comes to know that the collide is occur over there. So he has to wait for some time. And same can be happened over there. Whenever a collision is occur over here, whenever the C's collision is detected and the packets are aborted, so what it means, so C automatically comes to know that the collision is occur over there, and he has to wait for some amount of time. So this is the working of CSMA/CD. CD means the collision detection. So look at the description of this diagram. In the diagram, A starts send the first bit of the frame at the time T1. Since C sees the channel idle at the T2, it starts sending its frame at the T2. C detects A's frame at T3 and aborts transmission. So what it means, whenever A detects the A check the transmission media and it becomes the idle. So at the very that same time, A sends its data. Whenever a C detects that the this particular channel is idle, so the C sends its data, but at the time T3, there is a collision occur over there, and C detects that the collision is there and the number of packets, they are aborted. So what you can say, the transmission is aborted. The next is the A detects the C's frame at T4. System A detects the C's frame at the time T4 and aborts its transmission. Transmission time for C's frame is therefore, and the A's frame is. Now look at here. A detects the C frame at the T4 time. Now look at the diagram. At the time T4, this is the time T4, the collision is occur over there. And this arrow is coming from the towards from the C. So what it means, A sends its data at the time T1 and B sends its data on the time T2. But whenever a time T4 is there, the collision is occur. So what it means, whenever A sends its data, that's the time T1 is there. Channel is idle, it sends data. At the time T2, C detects that the channel is idle and it also sends its data. But after a few seconds, whenever a time T4 is there, both the packets of coming from the user A and the user C, they can be collide over there. Look at here. They can be collide over there. So what it means, the collision is occur and the transmission is aborted. So the frame transmission time, that is you can say TFR, the time for the frame, should be at least twice the maximum propagation time. This can be deduced when two stations involved in a collision are a maximum distance apart. So what it means, whenever a collision is occur over there, we have the frame transmission time. So frame transmission time means we have to wait for some time. After the waiting of that time, again we resend the data. So that might be happened at the that the user A and C, they have to wait for the same time and send its data. So again, the number of chances are there that the collision can be happen over there. So we have to make the at least twice the maximum time for the propagation time, and the propagation time is the delay time, delay, or you can say the waiting time for the stations. So next we have the entire process of the collision detection can be explained as follow. Now look at the your screens very carefully. Now from where the process is start. Whenever a k is zero means the whenever you can say the channel is idle and we start the transmission. Now apply one of the persistence method, either for the one persistence, non-persistent, and p-persistent. These method can be you can go through with these methods in the next slide. We can use any one method. Suppose at starting we are using one method. Whenever transaction done of collision detected, if the collision is there, yes, what it means, if the collision is there, then go to the step down. If the collision is detected, now if the collision is detected, so what it means, yes, then send a jamming signal. So what it means, whenever a collision is detected, it sends the jam signals to all the users. So whenever the users they receive the jam signals, they come to know that some type of collision is occur over there, so they have to wait for some time. Whenever it sends the jam signals, now the value of k is equal to k plus 1. Why the k? Look at the starting, the k is 0, the initial time is there, the collision is occur, so they have to wait for some time to resend its frame. That's why the k value is increased by 1. Now if the k is max, is the k is greater than k max, if yes, then abort the messages. What it means, if the remaining time, that is maximum to the propagation time, that the time the system have to be wait, then simply it can abort it. If that time is not greater than this, then choose a random number of r between the 0 and the 2 raised to power k minus 1. So what it means, then we have to choose a random amount of time, that we are going to wait for some amount of time. It depends upon us. So the wait tb time, that is the frame time, the wait for that frame time, we decided one of the value, then again start with the same process. This is whenever a collision is detected. Suppose if collision is not detected, here transmission done or collision detected, if yes, then we have to follow this process. If no collision is detected, then the process is very simple. What is written over here? Transmit and receive. If no collision is there, automatically the frames they are transmitted and successfully received by the receiver. So this is all about the functioning and the process of transmission carrier sense multiple access with collision detection. Now the next is the persistence method. What should a station do if a channel is busy? What it means, suppose I sense the channel and the channel is busy. So what can be done from my side? Now the channel is busy. But what I am doing after this by checking whenever a channel is busy. So what should a station do if a channel is idle, or whenever a channel is idle, what can I do? I immediately send the message, or I have to wait for some time? There are three methods of answering this question. So whenever any user who wants to send the data, it first sends the channel. Two options are there. Either the channel is busy, or either the channel is idle. Suppose a channel is busy, what will be happen? If a channel is idle, then what should the station do? So to come up with these answers, we have the three different methods, or you can say the three different persistence methods are there. The first one is, look at on your screens, one persistence method. Second, non-persistence method. And the third one is p-persistence method. So let's start with the first method, that is one persistence method. The one persistence method is simple and straightforward. It is a simple method. And this method, after the station finds the idle line, or whenever a station who finds the channel is idle, it sends it frames immediately. Whenever suppose you want to send your data and you are using the one persistence method, whenever you find the channel is idle, immediately you send your packets with the probability 1, that is the initial probability. When the transmitting node is ready to transmit, it sends the transmission medium for idle or busy. So what will be happen? Suppose I am a transmission node. Transmission node means who wants to transmit the data. I simply sense the channel. Whenever a channel, I found the channel is idle, immediately I send my packets. If idle, then it transmits immediately at the same time. If busy, what will happen if the channel is busy? If busy, then it sends the transmission medium continuously until it becomes the idle, then transmit the message unconditionally. So what will be happen? I check this. Suppose I am a transmission node. I want to send my data. I sense the channel. The two options are there. Either it is idle or busy. Suppose the channel is idle. Whenever a channel is idle, immediately I send my data. And the second option is the channel is busy. So I continuously sense the channel. Continuously. Busy, busy, busy. Whenever it found idle, at the very same time, I send my data. In a case of a collision, the sender, suppose whenever a collision is occur, then what will be happened? The sender waits for a random period of time and attempt the same procedure again. Suppose I send the message and some collisions are occur over there, then I have to wait for a random time. Random means either it should be 1 minute, 2 minute, 2.5 minute, 3 minute, 5 minute, any value is there. Then I have to wait for a random amount of time and attempt the same procedure. So what will be happen? Again, start the same procedure. This method has the highest chances of collision because two or more stations may find the line idle and sends their frames immediately. The maximum chances of collisions can be happened in the one persistence method. Why? Because at the very same time, more than one systems that try to sense the channel, and that might be happened at the very same time. They both the channels, they find the channel idle at the same time and they sense their data immediately on the same time, and there are the maximum number of chances that the collision can be happened over there. Clear? So this is the diagram. Now that look at here, the time is there. It starts, the work starts from here. Continuously sense, we can say, we can read it in the definition. We continuously sense the channel. Sense busy channel. This is the busy one. The dark, the channel that is shown in the dark black, that is a busy. Whenever a channel is busy, it continuously sense. Look at here, sense and transmit. Why? Idle channel, whenever it founds the channel idle, immediately it sends the data. Whenever a channel is busy, it continuously sense and whenever it finds the channel idle, it same time sends and transmit the data. So what will happen? Look at here. Now look at the diagram over there. The looping state is there. Suppose it sends the channel. Only the two things can be happen. Either the channel is busy or the idle. If idle, station can transmit. If busy, again goes back, then check the channel. Busy, again goes back, check the channel. Busy, again goes back, check the channel. What it means, in the case of one persistent, the sender continuously sends the channel. If the channel is busy, it continues its sensing. Whenever it finds a channel is idle, at the same time, it sends the data. This is all about the one persistence method. So the next is non-persistence method. It is the second one. In the non-persistence method, a station that has a frame to sends the line. The first process is same. If I am a station who wants to send the data and I am using the non-persistent method, first I sense the channel. If the line is idle, it sends immediately. If the line is idle, second process is same. If the channel is idle, immediately I send the message. If the line is not idle, the second option is there. If the line, or you can say the channel is busy, it waits a random amount of time. This is the difference. What will be happen in the one persistence? It continuously sends. But in the case of non-persistence method, if the channel is idle, then it has to wait for a random amount of time. Suppose that random time is, take an example, it is of 2 minutes. So what will be happen? It waits for a 2 minute. Again, after the completion of 2 minutes, it again sends the channel and then sends the line again. Then again sends the channel. What will be happen? Again, it sends the channel. If the channel is still busy, then it again wait for a random amount. Suppose now the random amount is 3 minutes. Now it has to wait for a 3 minutes. After 3 minutes, again it checks the channel. If the channel is idle, it immediately sends. If the channel is not idle, then again it wait for a random amount of time. The non-persistence approach reduces the chance of collision. It reduces the chances of collisions as compared to the one persistence. Why? Because it is unlikely that two or more stations will wait the same amount of time and retry to send simultaneously. Why the chances of collisions are less as compared to the one persistence? Because whenever suppose I and Shehzad, we both sense the channel at the same time, we both feel that the channel is idle, the channel is busy. Whenever a channel is busy, then we both are wait for a random amount of time. My random time is 2 minutes, for example, and Shehzad random amount of time is 3 minutes. So what will happen? After 2 minutes, I sense the channel and the channel is idle. I send the message. But Shehzad can check that particular channel after 3 minutes. So what is the difference? The time difference is there. So that's why there are a less number of chances of the collision. So the non-persistence approach reduces the chances of collision because it is unlikely that two or more stations will wait the same amount of time and retry to send simultaneously. However, this method reduces the efficiency of the network because the medium remains idle when there may be stations with frames to send. This channel, it reduces the chances of collision, but one thing that it also reduces the efficiency. Why it reduces the efficiency? Because the waiting time is random. And suppose my waiting time is 2 minutes and Shehzad waiting time is 3 minutes, at least 2 minutes. If the channel is idle, no one is going to sense that channel because I have to wait for 2 minutes and Shehzad has to wait for 3 minutes. So this is non-persistence method. And look at the diagram is there. Let's start with this. Channel busy. Sense it at this point, it sends the channel. If the channel is busy, then again it sends at this time. No continuous sense is there. The wait random amount. It has to wait from this time to this time. Random amount of wait kiya, then it sends the channel. Again the channel is busy. Then again it wait for a random amount of time and it sends the channel at this point. Whenever it sends at this point, the channel is idle, it simply transmits the channel. Now this is the point that at this time, look at audience screen, the channel is idle, but it has to wait for a random amount of time. So this idle time remains waste for all the users. Same with this looping one is there. Look at the channel. If the channel is busy, wait a random amount of time. After random amount of time, it can check the channel. And again, if the channel is busy, again the random amount is there. And if the channel is idle, it simply transmits the channel. It simply sends the data and the station can simply transmit its data. So this is one persistence method. And the next method is persistence method. When the transmitting node is ready to transmit data, it sends the transmission medium for idle or busy. The first process is same. Whenever a transmitting node who want to send the data, first it checks the channel. And what will be happen? Oh, the two options are there. Either the channel is busy or either the channel is idle. If idle, then it transmit immediately. The first step is same. Whenever a channel is idle, it transmit immediately. If busy, then it sends the transmission medium continuously until it become the idle. Then transmit with the probability P. Now the difference is there. Whenever a channel is busy, so what will be happen? Then it sends the transmission medium or the channel continuously until it becomes the idle. And whenever it becomes the idle, then it transmits its data with the probability P. A probability P means it gives some value to its frames of the P probability. If the node does not transmit, it waits until the next available time slots. So what will happen? A next concept is there. The time slots are there. If the transmission medium is not busy, or you can say it is idle, it transmit again with the same probability. If the channel is idle, it sends with the same probability. That means the probability P. Suppose want to send the message. If the channel is idle, I sends my frames with the probability P. And if it is busy, then I continuously sense the channel. Then I have to wait for a particular time slot. After the completion of these time slot, I again check the sense the transmission media or sense the channel. And if again the channel is idle, then I again sends my frame with the same probability. And that same probability means with the same probability P. The P persistence method is used if channel has time slots. Whenever we are using the P persistence method, whenever a channel has a time slots are there. And with these slot durations equal to or the greater than the maximum propagation time. The P persistence approach combines the advantages of the other two strategies. It reduces the chances of collisions and improves the efficiency. Now, the P persistence approach, in this case, we have the time slots are there and the time durations, they are equal or greater than the maximum propagation time. And the maximum propagation time means the maximum waiting time. In previous cases, we discussed the maximum propagation time means we are discussing the random amount of time that we have to be wait. This is called the maximum propagation time. Suppose the random amount of times are 2 minutes, then the this particular time slot time is equal to 2 minutes or greater than the 2 minutes. Clear? So in this case, with the help of P persistence, the chances of the collisions are less and the efficiency is improved. Why the efficiency is improved? Because they have the time slots. The number of chances of collisions are less because every station they wait for that particular time slot and sends its data. Whenever a data is sent, then they have to wait for another time slot. So this is the working of P persistence method. Now look at the diagram. Continuously senses there whenever a channel is busy. Whenever a channel is idle, at this point the channel is idle, but we have a time slots. Either you send the data in between this time slot. If time slot is gone, then you have to wait for another time slot. If this is gone, then you have to wait for another time slot. So what it means, it has the time slots are there. Suppose a time slot is of 1 minute. So you have to send your data at the initial of this, one minute. If that time is goes, then what will be happen? Then you have to wait for another time slot. So the probability outcome does not allow the transmission because the probability outcome remains the same and they have to wait for another time slot. Now look at this diagram. The second one is there. Two conditions are there. It check the channel, either the idle or the busy. If busy, again check the channel, again check the channel. And idle, now it checks the probability outcome, either the probability P, either the probability P minus 1, either the probability P minus 2, P minus 3, and so on. If the probability is less than equal to P, that is the common initial probability, station can transmit. If it is less than that P, then wait a slot. And what is that slot? This is the time slot. Then he has to wait for a time slot, then again check the channel. If the channel is busy, then it act through a collision occurred and start again. Then what will be happen? A collision is over there. If the channel is idle, then again wait for a time and again check the probability. Whenever it checks the probability, if the value of probability is equal, then it sends the data. Otherwise, it has to wait for some amount of time. So this is the process, or you can say the dramatical information about the P persistence channel. So in this method, after the station finds the line idle, it follows these steps. Now they write the working of the P persistence in the form of steps. So what will be happen in the step 1? With the probability P, the station send its frame. And this is, you can say, the basic probability, the initial probability. At the step 2, with probability Q is equal to 1 minus P. 1 minus P means now the probability is less. The probability is minus from 1. The station waits for a beginning of the next slot and checks again. Whenever a probability is less, then it has to wait for a time slot. Then again, if the line is idle, it goes to the step 1. If again it finds the idle, goes to the step 1. But in step 1, again it sends with the probability P and station can send its frame. So if the line is busy, it acts as through a collision occurred and uses the backup procedure here. So this is all about the persistence method. Now the next is the carrier sense multiple access with collision avoidance, that is CA. Now CSMA protocol comes with the collision avoidance. Now we are going to avoid the collision. In the previous one, the collision is occur over there and we are going to detect the collision. But we have the second option, or you can say the second version of CSMA, that comes with the CA option, and CA stands for collision avoidance. Now we avoid the collision. So let's start with this. The basic idea behind the CSMACA is that the station should be able to receive while transmitting to detect a collision from the different stations. In wired networks, if a collision has occurred, then the energy of received signals almost doubles and the station can sense the possibility of the collisions. So what will happen in this case? All the transmitting channels who want to transmit the data, they have to detect a collision from a different signals, or you can say from a different stations. So what will be happened if any collision is occur over there on any station? All the stations, they are able to detect the collision. So normally in the wired networks, I mean where the wired transmission media is using, if the collision has occurred, the energy of the received signals, or you can say the power of these signals, they becomes the double, and stations can easily sense the possibility of collision. So all the stations comes to know that some collision is occur in the station. So that's why it comes with the collision avoidance. In case of wireless networks, most of the energy is used for transmitting and the energy of received signal increased by 5 to 10% if a collision occurs. In the case of wireless networks, whenever a collision is occur over there, the normally the signals energy can be increased, or you can say the power of the signals can be normally increased by the 5 to 10%, or whenever it can be happened. So they come to know that some type of collision is occur over there. So it can't be used by the stations to sense collision. So they cannot try to sense the collision automatically. Therefore, CSMACA has been specially designed for the wireless networks. So that's why the carrier sense multiple access collision avoidance channel, they basically, or you can say the specially designed for the wireless networks, or you can say this can be used in the wireless networks. CSMA/CA. So basically, these are the three type of strategies, or you can say the three different methods we are going to use in a CA method to avoid the collisions. Now, the first one is IFS, or you can say the interframe space. When a station finds the channel busy, this can be happened in the case of whenever a channel is busy. Suppose you sense the channel and the channel is busy, it waits for a period of time called IFS time. Now it waits for some random amount of time, and that random amount of time is known as interframe space. Now you can say this random amount of time name is IFS. IFS can also be used to define the priority of a station or a frame. Also, the interframe space, we are used it to define the priority of a station or a frame, that what is the priority of this station to send the data, or what is the property of the particular frames that are going to be transmitted. Highest the IFS, higher the IFS, lower is the priority. Highest means if the IFS is greater, interframe space time is more, automatically the priority is lower. If the IFS value is greater, the priority is less. Now the second, contention window. It is the amount of time divided into slots. Now we can divide the time into the different slots, and these slots are known as contention window. A station which is ready to send frames choose the random amount of slots as wait time. Now, if a station who wants to send its data, he has to wait for some random amount of time, and these random amount of times are the time slots. And in this case, in the case of CA, collision avoidance, these time slots are known as contention window. So what it means, they have to wait for some contention window time. And the last one is acknowledgement. The positive acknowledgement and the timeout timer can help guarantee a successful transmission of a frame. Now the acknowledgement concept is there. Whenever I send some data towards you and you send the positive acknowledgement. Whenever I received this acknowledgement, I come to know that my frames are positively received by your side. So these are the three different strategies, or you can say the three different methods that are used in the case of collision avoidance to avoid the collisions. Now this is the process. Now look at the process very carefully. The entire process for the collision avoidance can be explained as follows. So let's start with this. Whenever a process is started, the initial value is 0. Now what will happen? Only the two cases are there. Either the channel is busy or not. Idle channel? No. The channel is not idle. Again, it sends the channel. Look at it. No. Then again, the arrow comes to this side. Suppose the channel is yes. Channel is idle. Wait IFS. I want to send the data. Channel is idle. I have to wait for interframe space time. Now the IFS, I have to wait for IFS. After the waiting of IFS, still idle. Then if still not idle, then again goes to the first step. Then again check the channel. If the channel is idle, then wait for IFS. If now after waiting the IFS, the channel is idle, then choose a random number between R and 0 and 2 raised to power k minus 1. So what it means, now you can choose any probability with your frames and wait R slots, and these slots are known as the contention window. Then again you wait for some contention window, then send the frame, then the waiting time is out. So what will be happen? Acknowledgement. Then I am waiting for the acknowledgement. If the acknowledgement received, the success is there. What it means, my frames, they are successfully received by you. If no acknowledgement is sent, I send the frames but acknowledgement is not received, then k is equal to k plus 1. Then we have to wait for next k, next time amount. Then again, if the k is max, k is greater than k max. K max means the maximum time. If that waiting time is greater than that maximum time, if yes, then abort the message. So what it means, no, there is no need to send the chain, no need to send the frames. A collision is occur over there. If no, if it is less, then again start with the first process. Then look at here. Let's start with the first process. And what is the first process? Again, it repeat the process. It sends the channel and detect whether the channel is idle or busy. So this is all about the collision carrier sense multiple access collision avoidance, or you can say the collision detection. So this is all about the CSMA protocol, or you can say carrier sense multiple access protocol.